light source. At least 7 modules are needed to obtain 1 kW blue laser. Power of 7 modules are measured and data is shown in this figure. Based on fiber tapering and fusion splicing, a 7-to-1 fiber optic combiner is produced. A combining efficiency of 90% is achieved. We manufactured power supply control system and QBH transmission fiber. This right figure shows power measured after beam combination. The figure shows photo of the blue laser system. After 1000 hours of aging under the condition of 2.5 ampere current and 20 degrees water cooling, the power attenuation of the unit is less than 3%. Copper, stainless steel, and aluminum samples are welded to test the performance of the system. Collimating lens, focus lens, and protective lens are integrated in the welding system, but all lenses are not spherical aberration eliminated, which will have a negative impact on welding penetration. Spherical aberration eliminated lens group will be used as one of the optimization methods in the future. These lenses have anti-reflection coating that allows a transmission more than 99% for blue laser. With a magnification of 1.5, the diameter of focal spot on workplane is about 0.5 mm. Again is used during welding process. We use 500 watts power to weld 0.3 mm red copper sheet at different speeds, and the speed of 30 mm per second can penetrate. The width of the weld bit on top surface is 0.63 mm. The bottom width of the weld bit is 0.33 mm, and the actual thickness of the copper sheet is 0.35 mm. The thickness increased to 0.6 mm and the power increased to 1 kW at the same time. The speed of 20 mm per second can penetrate. The width of the weld bit on top surface is 1.26 mm. The bottom width of the weld bit is 0.79 mm. Changing the metal to aluminum plate with 0.5 mm thickness, we use 500 watt power and the speed of 30 mm per second can penetrate. When the speed is 20 mm per second, the width of the weld bit on top surface is 1.01 mm. The bottom width of the weld bit is 0.65 mm. Using 500 watt power to weld 0.5 mm stainless steel plate at different speeds, the speed of 50 mm per second can penetrate. Under 30 mm per second, the width of the weld bit on top surface is 1.05 mm. The bottom width of the weld bit is 0.52 mm, and the actual thickness of the stainless steel plate is 0.43 mm. 1 kW power on 1 mm stainless steel plate. The speed of 25 mm per second can penetrate. When the speed is 20 mm per second, the width of the weld bit on top surface is 2.35 mm. The bottom width of the weld bit is 1.42 mm. We also performed welding tests on both copper and aluminum plates of 1 mm thickness. The performance of blue laser was maintained well. Welding aluminum and copper together presents a challenge because of the large different absorption and melting points of the two materials. The blue laser shows a good result of switch welding between copper and aluminum. The power is 1 kilowatt with a speed of 28 millimeters per second. In all the tests above, a high quality heat conduction weld and smooth surface on the samples was shown, and the whole process is very stable without splice and all cross sections have no pores. Finally, for the point welding of stainless steel, we have made a comparison between blue laser and air laser. The left is air laser and the right is blue laser. From the video, we can find that there is no spatter during the whole processing of the blue laser. Test data shows the blue laser source is suitable for processing of high reflection metals, as copper and aluminum have important application in many fields like battery on new energy car and 3D printing of aerospace parts. It's believable that high-brightness blue laser will play an important role in manufacturing of high-end equipment. That's all. Thank you.